All right, so formal charge can actually help us out when we're trying to decide between several Lewis structures that look like they might be comparable in terms of which might be the lower energy or the more stable structure. The examples we've done so far have been pretty straightforward, so we haven't needed to use formal charge to make this kind of decision. But we could, for example, look at a case where we have several different structures that look pretty good, and the one we want to determine as being the lowest energy structure is the one in which the absolute values of the formal charges are going to be lower, so essentially that they have less charge separation. Those are going to be the more stable or the lower energy structures. So for example, let's look at thiocyanate ion. We have C, S, and N. What we've learned so far is as a first approximation, what we want to do is put the atom with the lowest ionization energy in the middle here. So let's compare those ionization energies. We have 1090 for carbon, 1000 for sulfur, and 1400 for nitrogen. So thinking about ionization energy, which atom would you put in the middle here? So a lot of people I hear saying sulfur, and that's right. So in terms of ionization energy, we would expect to see sulfur in the middle. So if we went through and drew out our Lewis structure following each of our steps, what we would get is this as our Lewis structure here, and we could figure out all of the formal charges. But what I'm going to tell you already is this is a case where, in fact, it's an exception to the idea that the lowest energy structure has the lowest ionization energy in the middle, and we can figure this out when we look at formal charge. It's always a good first approximation because you need to start somewhere in terms of drawing Lewis structures, but then if you go and figure out the formal charge and you just have lots of charge separation or very high charges, like a +2 and a -2 and a -1, all different places in the atom, what it should tell you is maybe there's a better structure. So let's think of all of the combinations that we could have in terms of this molecule. So in one case, we could actually put carbon in the middle. In one place, we could put sulfur in the middle. And in one case, we could put nitrogen. And then we can go ahead and let's quickly write out what the formal charges for all of these will be. So in our first structure, we would find for the nitrogen, we have a formal charge 5 - 4 - 2 because we're starting with 5 valence electrons. So that is a formal charge of -1. For the carbon, we start with 4 valence electrons. We have 0 lone pair electrons, -4, and we end up with a formal charge of 0. For the sulfur, we start off with 6 valence electrons, -4 lone pair electrons, -2 taking into account our bonding electrons, so we end up with a formal charge of 0. All right, so this looks pretty good. We don't actually have much charge separation in this case here. Let's take a look at the lowest ionization energy in the center case. And what you find out if you do these calculations is that you have a -1 for your formal charge on nitrogen. You have a -2 for your formal charge on carbon, and you have a +2 for your formal charge on sulfur. If we look at our last structure here, where we have nitrogen in the middle, we can also figure out all those formal charges. And in this case, we have +1 on the nitrogen, we have -2 on the carbon, and then we end up with 0 on the sulfur there. So let's go to a clicker question. If we call this structure A, B, and C, you can look on your notes. It also says structure A, B, and C on your notes, so you didn't need to just memorize that slide. But I want you to tell me, in terms of thinking about formal charge, which Lewis structure would you predict to be the most stable? And this should be fast, so let's take 10 seconds on this. Okay, great. So let's go back to our notes here. And the reason that this should be so fast is we already did all the calculations for the formal charges. So what we see is that structure A is the most stable because we have the least separation of charge in the case of structure A. And you can do this anytime if you have Lewis structures that you're choosing between. You won't always draw out every single possibility that you have to start with. Often a good thing to start with is to put the lowest ionization energy atom in the middle. And if you don't have charge separation, then go with that structure. But if you do find you have a lot of separation, such as the case in -2, +2, and -1, then you want to say, wait a second, this is really bad in terms of formal charge. Let me go ahead and see what other options I have here. So we can also get into a case where we have the similar values in terms of absolute values of formal charge between two different molecules we're deciding between in their Lewis structures. And in this case, the tiebreaker goes to the molecule in which the negative charge is on the most electronegative atom. So let's look at an example of this here. So we could say, for example, this molecule here. This now we're dealing with a lot of different atoms in the molecule, much more complicated than the initial case of the cyanide ion where we only had two. So how do we figure out first how to draw the skeletal structure of this molecule here? And one thing I want to tell you to start out with is something about this CH3 group here. Anytime you see a CH3, this means a methyl group. And if you draw out what a methyl group is, hopefully you won't have to spell it, methyl, then what you have is a carbon in the middle with 3 hydrogens around it. And then it can only be bonded to one other thing. So anytime you see CH3 here, remember that that's methyl, and that's going to be a terminal group. So you already have a hint that methyl groups are never in the middle. They always have to be on the outside. So that's a good start for us putting together a skeletal structure for this compound here.